Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are continuing our study of sequences and series, and we are going to talk about arithmetic series. So let's get to it, shall we? All right. So that's the Great Cranberries, and we'll get back to them. So we've already talked about this in class a bit. An arithmetic series is the sum of the terms of an arithmetic sequence. So if I have this sequence right here that is increasing by 2, so it has a common difference of 2, and I add up every single one of those terms, that is a series. The series is actually the sum after I'm done adding. And this is finite. You know, it's finite because the series stops at 49, or the sequence stops at 49. If it was infinite, an infinite arithmetic sequence, we can't find the sum because it goes to infinity. That'll change for some geometric series, but that's the next video. Okay, this should be pretty quick. The sum of a finite arithmetic series. This just kind of runs through a proof of where some of the formulas come from. If we say that u sub n is the final term, you have seen how we can get, if this is the first term, we can get the next term by adding d and the term after that plus 2d, and on down the line until I get to u sub n. Okay, and if I reverse them and then do some algebra, I can get twice the sum, or twice the series, which is the sum of the sequence terms, equal to n times u sub 1 plus u sub 2, and I get this general formula for the sum of an arithmetic series. And then I can also use this to find a particular term, if I need it. And then with some other algebraic manipulation, if I don't have the first term and the last term, I can replace u sub n with what we have here for the finding the other term. So we will be using these quite a bit to find the sum of some series. Okay. So I can find the sum of this series right here, which is arithmetic because the common difference is 3. And I have two choices. I can use this formula or I can use this formula. And clearly this is the easiest one, but I have to know the first term and I have to know the last term. Okay, I'm going to use, well, I think I'll go ahead and use this one. Because I could find the last term, but I'm just going to be doing most of what I'm doing here anyway. Okay, so S sub n, I'm just going to rewrite it for us, is equal to n over 2 times 2u sub 1 plus n minus 1 times the common difference d. Okay, so here we're finding the sum of the first 50 terms, so that means n is 50, so S of 50 is equal to 50 over 2 multiplied by 2 times the first term, which is 4, plus, now n is 50, so then 50 minus 1 is 49, so that's 49, multiplied by the common difference, 7 minus 4 is 3. So easy peasy, so this becomes 25 times 8 plus 3 times 49, 3 times 50 is 150, so that's going to be 147. Okay, and then that becomes 25 multiplied by 155, I believe. Do I have that? 47, 57 minus 2, 155. Okay, which is equal to 3,875. So the sum of the first 50 terms of this sequence is 3875, which makes it a series. Okay. One more example, find the sum of this series. Okay. So I do know the first term, right? And I know the last term. So I could use this formula, but I don't know the number of terms. Okay, I don't know how many terms are in this sequence, and it looks like there's, or this series, and it looks like there's quite a bit. But I can use my formula to find a specific term, this one, to find the number of terms simply by solving for n. And we've done that several times before. Okay, so I want to know what this last term number is. And I know it is equal to 141. I know the first term is equal to -6 plus n minus 1, and when I solve for n, I'll have this term number because that's this right here. It's the same n, and then the common difference is 7. So 141 equals -6 plus 7n minus 7. 141 equals, let's see, -13 plus 7n. I add 13 to both sides, I get 154 is equal to 7n. So I believe that is going to be equal to 22. So there's 22 terms in that sequence. And so to find the sum of those terms, pretty simple. I would use this formula, n over 2 times the sum of the first and the last terms. So that would be, or u sub n I should say. And my n, so I'm doing s of 22, so that's 22 over 2 times -6 plus 141. So that's going to be 11 times 135. And 11 times 135 is equal to 1,485. So the sum of all the terms in this sequence from -6 to 141 is 1485, 1,485. With that, I am finished with the arithmetic series. Hope you enjoyed it. Next up is geometric series, and let's check in with the cranberries, shall we? See how they're doing. And with that, I am out.